looking at solving questions, and sometimes when you have a sine 2x or a cos 2x, you can use one of our new formulas, and sometimes when you have a sine 2x and a cos 2x, we should do it like we did earlier when it's a multi-revolution question. So now this makes things more difficult because you have more options. So one of the things is, how do you know which option to use? Should you think of it as a multi-revolution question, or should you think of it as a double angle identity? And basically it comes down to, if the only trig function you have is the double angle, then you can think of it as a multi-revolution. However, if you have another trig function in the question, then you should think of it as a double angle formula. So, a review first of the multi-revolution. Here we have cos 2x, it's the only thing in the function. So I'm going to solve this like a multi-revolution question. And a reminder, in the multi-revolution question, first we say the domain for 2x. Well, if x was between 0 and 2 pi, then 2x would be between 0 and 4 pi. We solve for 2x. This is on your pi plate. This is your pi over 6 family. Cos is root 3 over 2 with your pi over 6 family. It's positive, so we look in quadrant 1 and quadrant 4. That's the first time around. The second time around, we need to say what is coterminal with this, and you would have to add 2 pi, and a reminder that you can make 2 pi 12 pi over 6. So if I add 12 to this, I would get 13 pi over 6, and add 12 to this, I would get 23 pi over 6. Then to solve for x, divide everything by 2, which is the same as multiplying by a half. And we get 4 answers. So that's a review of multi-revolution questions, where you restate your domain for whatever the angle is, solve for that angle, but this time we had to go 2 times around, and then get x by itself. If you have an extra trig function like this sine x in there, then it probably makes sense to go to your formulas, your double angle formulas, and the only thing you can change sine 2x to is 2 sine x cos x. Then if you are tempted to divide, in this one you'll be very tempted to be like, oh, if I divide both sides by sine x, it will go away. That is not allowed in this case, so we have to factor instead. So what's going to happen? I'm going to rewrite this 2 sine x cos x. I'm going to subtract the sine x on the other side, make it equal to 0, and then I can factor out the common factor of sine x. Okay, when I take out the sine x, this 2 sine x doesn't mean I have 2 sine x's. I have a 2 times the sine x. So when I take that sine x out, I'm still left with the 2 and I'm left with the cos. But the sine has been pulled out. Minus 1, and then from here, we can solve. So sine x is equal to 0. Sine is your y coordinate. That happens at 0 pi and 2 pi. Cos x equals 1/2. That's your pi over 3 family in quadrant 1 and quadrant 4. So, one thing, if you have a solving question and it has a 2x in it, it might be a multi-revolution question, or it might need one of your identities. But you won't be able to solve it directly if you have an extra trig function. Do the change, see if you can factor things out, and now we're ready for the last example, which was in your textbook. Example 4. which is solving. So once again, here, we have a double angle identity. We have to decide, should this be a multi-revolution question, or should I use one of my identities? And because I have another co-squared function in this, I should use one of my identities. I'm going to change that to 2 sine x cos x minus cos squared x equals 0. The 1/2 and the 2 will cancel out. And now you can see you could factor out a cos x. And if we split it up here, this is very solvable. This is a little bit tricky. Because in order for that to be equal to 0, sine x would have to equal cos x. There's 2 ways we can solve that. First, we'll do this one easy. When is cos equal to 0? That's your x coordinate. Your x coordinate is equal to 0 at pi over 2 and at 3 pi over 2. Sine x equal to cos x. You could do this from your unit circle, and you just have to think, when is my x coordinate and y coordinate exactly the same? Well, in quadrant 1 at pi over 4, they're both root 2 over 2. And in quadrant 3, at 5 pi over 4, they're both negative root 2 over 2. Or you could also solve this if you divided both sides by cos. That would change it to tan x equals 1. And you would find that tan is positive 1 in quadrant 1 and quadrant 3. You would get the same answers that way as well. Alright, I have lots of questions for you to do on this. So in the textbook, you can circle questions 12 to 15. And on the back side of the handout that had all the proofs, we all call it the proofs handout. On the back side of the proofs handout, you can circle. There's some already circled. They're not the ones you should circle. 8, 9, 11, and 12, 14 and 15, 21, 27, 29, and 31.